Here's my moon phase inquiry activity with the original lesson and with the adaptation that I made for my 6th grade science class. Here's the original activity from ITSI, and I just took a video of what you would see on their website. It has a lot of questions discussing the use of a model. It does come up with an inquiry or an initial, like, here's what do you think about what causes the phases of the moon. It also states the standards that this activity meets and provides materials for something later in the activity. The first thing this one has people do are draw each of the moon phases without any kind of information prior to that. And then it has students make predictions about what phase this might be in based on where it's at. Then this activity uses a really nice, simple, interactive for students to collect data. This is nice because you can see how the moon travels around the Earth, and it shows the what it would look like. I can run that right for you here. And in the upper left-hand corner, it gives what that moon would look like depending on where it's at in relationship to the Earth. And the other thing I like is that you can always see that the moon is always half lit in this diagram as well. And it has students use this interactive a couple of times throughout the activity. The first time that asks about when it's in a new moon and a full moon, and explaining those positions, and then it goes on to talk about the waxing and waning phases of each of the moon, and include snapshots and things like that, so to show that students are doing it. This section is on the waning phases. Then it has students kind of, based on what they've seen through the model, they answer several different questions about the moon, such as, what does it change its shape? Does it make its own light? And then it does go on to talk about eclipses, which are related to moon phases, but it's a common misconception that students have with that. It includes some actual pictures and a summary question of explain what causes the phases of the moon. It also goes on to STEM careers and some questions about how the moon and stars were formed. And then it finally gets to the activity with a styrofoam ball and light source. This activity is aligned to STEM practices in a couple of different ways. One of the key things is about the developing and using models. I wouldn't call this carrying out an investigation, but I guess it could, because it does include recording some of that data based on the computer simulation and they having to analyze that. Students do have to construct explanations based on that data, and using that evidence they have to evaluate what causes the phase change of the moon and communicate that information through their answer. Throughout the scientific inquiry, they are engaging in scientifically oriented questions, and evidence and explanations are obviously key. The learner does connect their explanations to the scientific knowledge about the phases of the moon, and the learner does have to communicate and justify their explanations throughout those analysis type questions. This is my revision of the moon phase activity, and the major thing that I wanted to change was where the activity was actually located. I really didn't like the format of the online interactive, so I put everything into Schoology, and this one, it allows me to connect this to my gradebook, and I can see which students have answered questions and which one haven't very simply. And the other major thing that I changed was the order. I really wanted students to use the ball and light activity to show the moon phase pretty much straight away. So let me play this. to see how I change things. So I have students doing the ball activity first and making those observations. So before they learn anything about the moon phase names or anything like that. And then I just took several of the questions from the original activity and put them into here. I also chose a moon phase animation that was slightly different than the one. It had a little bit more information into it. Students could also change the rate of it. And the other thing that was nice about this one that I liked was as the moon traveled around the Earth, and you can see in the moon phase up here, it also changes the name, so students can see the name that goes with the phase as they're watching that interaction. So I also have them use that animation a couple of times to talk about the waxing phases and the waning phases. And then I also have some analysis questions. I use the same ones that were from the original one as well, but I did take out some of them just because I didn't want to have students get confused with, especially the ones about eclipses. I would like to move on I would like to have more of a discussion with eclipses after they've done all of the moon phases. And I added this last question, question 11, which just has them putting the moon phases in order. Here's the video of me making the model of the moon and the sun and the Earth. It's a very simple model. You can see I start with the sunlight coming in, and if you keep your eye on the ball, you can see the amount of light that you see on the ball changes as the ball travels around me, the Earth. It's coming on here where it would be a full moon, and as it continues around, you can see the lighted side is now on the left, and the amount of light gets smaller and smaller as it makes its journey around the Earth. And hopefully students would be able to see that as well. While it's a very simple activity to participate in, I think it can be really powerful for kids to actually see that the amount of light on the moon changes dependent upon where its position is around the Earth. Just a couple of extensions and some differentiation that I would use with these activities. Like I said, because the eclipses are closely related to moon phases, students could show the model, or could use that model to also show eclipses. Students could create their own moon phase calendar and record their observations about the moon for a 2 to 4 week period. And students could also create their own moon phase model. Based on the responses that students have to those questions, I could then group students for remediation or acceleration. That's a really easy way for me to see which students kind of understand the concept to a greater degree and which students need some more instruction or to change their misconceptions with some actual conceptual knowledge. Overall, like I said, it's a very simple activity for students to create. I think it can be very powerful for them to see that, since it's very difficult, since the Earth and Moon and Sun are obviously so large. You need to use those models to show things like moon phases.